Hello. Welcome to another exciting math video. Yay! From YouTube's least popular channel. But here it is. Today's subject is rational number types. So you already know a bunch of different types. You know the natural numbers, you know the the integers, and you know the natural numbers. We are going to introduce a new type. The type is called the whole numbers. Don't worry, it's very easy to understand. And then we're going to place some numbers where they belong in a diagram. The diagram is called a Venn diagram. Okay, so let's get started. Rational number types. First, we have the natural numbers. They are always positive. They have no fraction parts. They look like 1, 2, 3, 4, 5, etc. Here are some examples. 8 is positive and has no fraction part, so it is natural. 7 is positive and has no fraction part. It is positive. It is natural. 200, no fraction part and is positive. It's natural. 42, no fraction part, positive, no problem. 22 over 11 looks like a fraction a over b, but it is actually equal to 2, and what we care about is its value, not what it looks like. Since 2 is positive and has no fraction part, 22/11 is a natural number. 17.00 also looks like it has a decimal part, but really that has no value. That's actually equal to 17, which is no fraction part and is positive, so that is also natural. All of these numbers are actually also rational, because I could write 8 as 8 over 1, 7 as 7 over 1, 200 as 200 over 1, 42 as 42 over 1, 2 as 22 over 11, 17 as 17 over 1. They are also also rational. And in fact, all of them are also integers because they have no fraction part. And if it has no fraction part, it is an integer. Okay, here's the new one. Whole numbers. Whole numbers have no fraction parts, so they're still types of integers, and they're rational, but instead of having to be positive, they just can't be negative. Basically, it just means the only difference is the whole numbers and the natural numbers is the whole numbers include 0. 0 is the only whole number that's not a natural number. It's the most minor difference between types of numbers. Whole numbers are 0, 1, 2, 3, 4, 5, 6, etc., etc. It is part of the whole numbers. It is not part of the natural numbers. It is the only whole number that is not part of the natural number. So 0 is a whole number. They are also integers because they have no fraction parts. They are also rational because I can write them as a over b. Okay, next one. Integers, remember, doesn't matter if it's positive or negative or 0, but it has no fraction part. So like the whole numbers, so they are exactly like the whole numbers, but they can also be negative or positive or 0. So negative 17.00. Negative 30 over 5 is negative 6. So that's a rational number. And also an integer, no fraction part. Negative 42, negative 7, negative 3,000, 0, 8, 7, 200, 42, 22/11, which is 2, 17.00, which is 17. Negative 17.00 is negative 17. All of them, no fraction part. Some of them positive, some of them negative, one of them 0. All integers. So, integers are the big set. Whole numbers take away the negative integers. Natural numbers take away 0. That's the idea of those three. Finally, we get to the biggest set, rational numbers. Doesn't include all numbers. We talked about that there are things that are not rational. Not going to get into why they're not rational, but these can be written as a over b, where a and b are integers. It includes all the integers, but also some of the numbers that have fraction parts. So negative 17.5 is negative 175 over 10. Negative 32 fifths. See, 30 fifths is negative 6. Negative 32 fifths is negative 6 and 2 fifths. It has a fraction part. Negative 42 and 3/4 has a fraction part, but it can be written as a fraction, a over b. So that would be 168 plus 3 is negative 171 fourths, a over b. Negative 7.8, negative 78 over 10. 8 and 3/10, 83 tenths. 7.5, 75 tenths. All of these can be written as a over b. They have fraction parts, so they are not integers. These ones down here are not integers. These up here are all integers, but they are also rational. All of these numbers are rational because they can be written as a over b. There are numbers that can't be written a over b, things like the square root of 5. So, here is a Venn diagram. Notice, all the natural numbers are whole numbers. There is a whole number that's not a natural number. All the whole numbers are integers. There are integers that are not whole numbers, that are not natural numbers. All of these are rational numbers. All of these are also rational numbers, but some of the rational numbers are not integers. Okay? So let's place some numbers where they belong. Square root of 5, outside, it's not rational. How about 4? Okay, is it rational? Yes, I could write it as 4 over 1. But is that the best place for it? No. 4, does it have a fraction part? No. So it's an integer, but that's not the best place for it. 4, does it have no fraction part and it's not negative? Correct. So then it's a whole number, but is that the best place for it? 4, no fraction part and it's positive, so 4 belongs here among the natural numbers. It is also a whole number, it is also an integer, it is also a rational number, but the best place for it is in that tiny little circle in the middle. Okay, not even circle, shape, curvy shape. 0, 0 goes here. It is the only number that's a whole number that is not a natural number. What sorts of numbers are integers that are not whole numbers? Well, whole numbers can't be negative, so we want negative numbers. Does that mean negative 6 goes here? Yes. Does that mean negative 6.5 goes here? No, that's wrong, because integers have no fraction parts. So where would negative 6.5 go? It would go here in the rational numbers, because I can rewrite that as negative 13 halves. And that proves that it's rational. But it has to stay outside of the integers because it has a fraction part, the 1/2. Maybe I'll clean that up. There, cleaner. All right, how about 40 tenths? Well, it looks like it's a over b, so it's obviously rational, but isn't it equal to 4? And 4 doesn't have a fraction part, so it doesn't belong there. Let's put it here in the integer, 40 tenths. Okay, 40 tenths. But isn't that it's equal to 4, so which has no fraction part, therefore it's an integer. But is that negative? No, so it doesn't belong with the other negative numbers in that part of the integer circle, integer sector. So we'll put it in the whole numbers, since it is not negative. 40 tenths, right? 40 tenths. That's equal to 4. And where 4, is that 0? No, it is positive, so therefore it actually belongs here. And in fact, it's already there because it's equal to 4. They are the same number. They're just written different ways. How about negative 6? No, we have negative 6. How about negative 35? So negative 35, it belongs in the rational because it's negative 35 over 1. However, it is also does not have a fraction part, so therefore it actually belongs in the integers, negative 35. Does it belong in the whole numbers? No, because it is negative and whole numbers cannot be negative. All right, let's try another one. Negative 75 ninths. Negative 75 ninths. Now, obviously, that's rational because it's a over b. Does it belong in the rational numbers, or should I move it into the integers? Well, 9 goes into 75 8 times, but with 3 left over. So actually, this is -3, -8, and 3/9, which is -8 and 1/3. Therefore, it has a fraction part, so therefore it has to stay where it is. It cannot move into the integers. Got the idea? Okay. So I want you to be able to identify where numbers belong in this chart. And you want to be able to move them into the innermost circle that they can get to. You don't want to leave them stranding where they don't belong. Okay? If it can be written a over b, then it belongs in the rational numbers. If it doesn't have a fraction part, then move it into the integers. If it's not negative, move it into the whole numbers. If it's positive, move it into the natural numbers. I think I accidentally erased something, so let me rewrite that. Okay, that's it. Ask any questions that you have.